Now I am going to explain about the salt analysis. So children know any salt is having anion plus cation. Anion and cation, it can be one, it can be more than one in different cases. So this is the basic idea about the salt, as you know. You also know this thing that the anions have been divided into three groups. First is dilute acid radicals group. Dilute acid radicals group means the acid radicals which are detected. Anions are called as acid radicals. Why? Because the anions, they are decomposed by the acids to give the characteristic reaction, to give the characteristic identification, and hence they are called as acid radicals. Similarly, cations are called as basic radicals. So it is nothing like that. The cations are called as basic radicals, so they are detected using basic. Just in analogy with the acid radicals. Acid radicals are called as anions. So similarly, likewise, cations are called as basic radicals. So no relation, keep in mind. Now, dilute acid radicals, second is concentrated acid radical group, and third is independent radicals group. So there are the three groups of the anions, acid radicals, and dilute acid radical groups are sulfide, then sulfide. Similarly, concentrated, etc. There are many more: chloride, bromide, iodide, acetate, nitrate, etc. Independent, sulfate, phosphate, BO3, borate, etc. So these are the groups of the radicals. Now, how we come to know that which is the anion? So simply we take the salt. You take the salt. First I am starting with the dilute acid radical groups. So salt, lead salt is sodium sulfide. Salt is sodium sulfide, and we add dilute HCl. Just few drops of dilute HCl. It will be decomposed, and there will be formation of NaCl, and H2S will be liberated. H2S gas will be liberated or released, and hydrogen sulfide gas, it is colorless gas. It is colorless gas with rotten X smell. Rotten X smell. So we can identify this simply. Similarly, if there is SO3, SO3 will give SO2 gas. SO3, if there is any compound, let it be sodium sulfide, and so there will be, here there will be NaCl, SO2. So SO2 has its own identity, that SO2 is colorless gas with a smell like that of burning of fire crackers. Pungent smell. So we can colorless, pungent, slightly pungent, but less than chloride. You have to just carefully notice. It will be pungent, but pungency will be less than that of the chloride. And it will be suffocating. This is the real identification. It will choke our nostrils. or it will choke our voice, or it may appear, or it may say simply burning of firecrackers. Because firecrackers, they have the sulfur, and similarly here there is the sulfur, and so we can identify the point. Now coming to second, concentrated acid radicals group. So they are detected by concentrated, and we proceed on the concentrated group only when we are confirmed that the salt is not from the dilute group. So if we are not getting any information, any inference, then before proceeding to concentrated group, slightly heat the test tube, because some salts, they are not easily decomposed. Once again I am repeating, if you are having salt, you are unable to find the dilute acid radical, then before proceeding to concentrated group, first you heat slightly. Just allow it to slightly warm, not boil, because it may happen that by boiling the acid will become saturated or strong and it can decompose into the dilute group. So it is better just provide some temperature. Now coming to concentrated, so they are treated with concentrated sulfuric acid. And here we take the HSO4 concentrated. In any group, if you are not having any idea, then slightly provide some temperature. Little amount of temperature is provided so that it can undergo chemical change, because salts, they are in the dormant state. Some salts, not all, but some salts, they are listed depending on the conditions, depending on the weather also. If the test tube is wet, it means there are some chances of moisture, so it will decrease the intensity of the acid. So concentrated sulfuric acid, so there will be Na2SO4 plus there will be HCl. There will be HCl. So here in case of chlorides, you get the HCl gas, hydrogen chloride gas, and it is colorless. It is colorless gas with pungent smell. So we come to know if in concentrated group, concentrated acid radical group, you have added concentrated sulfuric acid to the salt, and if you are getting colorless gas with pungent smell. So in this case the pungency is very much strong, because chlorides are highly unstable by the sulfuric acid, because sulfuric acid is very strong perfluorizing agent, so it breaks. Now this, when we take the HCl gas and we put little amount of MnO2, then there is liberation of chlorine gas and there will be formation of MnCl2. This here it is a pale green gas in the same test tube. So here it is presence of chloride, and here it is the conformation. This is one conformation. Similarly, you can do other point, or simply you can bring what? Ammonium hydroxide. Glass rod dipped in ammonium hydroxide, so it will be there. And so this is the concentrated acid radical group. If there is not any dilute radical or concentrated, so the salt must be having the independent. And so independent radicals are the radicals which are neither responded by the dilute acid nor by concentrated. So we go as per the sequence. So for first we do test for the sulfate, then we go for the phosphate. There is a convention, nothing is written, but there is a convention that we go for the sulfate. And so for sulfate, what we do? We dissolve salt in water, add barium chloride solution, barium chloride aqueous, white PPT, then add concentrated HNO3, hot concentrated HNO3, then PPT is insoluble. PPT is insoluble. So you have to keep in mind that formation of white PPT is not conformation. Most of children they do like this. So this is the conformation. PPT add hot concentrated nitric acid or HCl or any mineral acid, hot concentrated mineral acid. PPT is insoluble. Why it is so? Because when we let it be NaCl4 plus BaCl2, then formation of BaCl4 plus NaCl. Now the barium is alkaline earth metal. Alkaline earth metal sulfates, they have very high enthalpy requirement. They are very high enthalpy requirement, and so they are not decomposed even by nitric acid. So this is the test which you have to keep in mind. Now coming to ketions. So ketions, they have been divided to 0 to group 6. 0 to group 6. Like 0, we have only one, it is ammonium. Then first we have lead, then second we have lead, mercury and many more. Third we have aluminium, then ferrous, then ferric, then fourth we have nickel, chromium, fifth we have calcium, barium, strontium, sixth we have magnesium. So this is the arrangement of the different ketions to the different groups. So in this, the most important is the start with the 0. Always start with the 0. This is first point. And second point, if we have, for example, if you have been given MgCl2, if you have been given MgCl2, then you have to start from this, and all the groups from first to fifth, they have to be reported absent. They have to be reported absent. Absence must be reported. Suppose you are given MgCl2 and magnesium chloride is highly hygroscopic. We prepare the packet, we have the solid, and if we wrap in paper, it may happen that within few hours or 1 hour, it will be completely, soggy. It will, it will appear to be molten. So you may guess that it is magnesium chloride. But even then you cannot write. You have to move as per the sequence. Sequence has to be followed. Now, see how we write. This is the experiment, observation, inference. We write in systematic manner. First, always start with 0. In case of anions, always start with the dilute. Even you have salt having the independent. Then, just write in a smart manner. Not too much. 3 points have to be recorded. Salt plus few drops of NaOH solution and heat. Few drops of NaOH solution and heat. Here no ammonical smell. 0 group absent. 0 group is absent. Then second, to the aqueous solution of salt. Here we have to throw. it. So this solution has to be discarded.
Yes, sir.
To the aqueous solution of salt and few drops. This has to be written, few drops, because in analysis we use minimum amount of chemicals as far as possible. So add few drops of dilute HCl. No white PPT. First group absent. Second, pass H2S in solution of experiment 1, experiment 2. So this has to be taken as it is. Just pass H2S, no PPT, second group absent. Now, boil off. This solution has to be boiled off with H2S. Boil off H2S from experiment 3rd and add NH4Cl and NH4OH. So boil off, then allow to cool. Then first add NH4Cl, little amount, so as to make it slightly, ammonical. And then add NH4OH. Here NH4Cl is added to increase the common ion effect, which will help in the precipitation. So again here there will be no PPT, so third group absent. Now coming to here again. Here add little NH4OH and pass H2S. Little bit of NH4OH has to be added. Here again, no PPT, 4th group absent. for group is absent. So this I have taken magnesium chloride as a reference point. So similarly, if your salt contains any member from group third, so you don't write the rest. Or if it contains cation of group 4, so do not do like this. Now next is, we have seen that fourth group is absent. Then boil off H2S from experiment 5 and add ammonium carbonate solution. Ammonium carbonate solution, here no PPT, so fifth group absent. Then last, if all the 6 are absent, then you can do test for magnesium. So we first informatory, then 2 confirmatory. And so this is the way how we write. Then at last, write down the result with the packet number. Packet number contains anion cation. So we do like this.